Hello, everybody. Welcome to the Neo4j online meetup. I think this is number 51. So welcome to everybody. If this is your first time joining us, if you have any questions while you're watching live, you can ask those on the chat on the right-hand side. I'll be watching that chat, so I'll answer any of your questions on there. While we're doing the presentation, there's going to be a bit of code in this presentation, so you want to make sure that you've got your resolution at 720p or higher. So make sure you have that set up. And what else do we need to do? If you're watching afterwards, we have the community site, and so if you have any questions, don't forget that you can always ask those on there as well. And I guess yes, if you haven't attended one of these before, my name's Mark. I work in the developer relations team at Neo4j, and today we're going to be talking about the BBC Foods graph, and I've got my colleague who can just see on the, I guess to my right, although to the left on the camera. So Lou. So I guess what we do with most of our guests on the online meetup is just give a quick introduction to yourself and maybe just a few sentences on how you got into Neo4j in the first place.
Yeah, so hi everybody, I'm Neo4j and I'm one of the field engineers here at Neo4j. So how did I get into Neo4j? So in a previous life, I was looking at master data management and how, effectively the usual, how do we look at the lineage, how we join in the various parts of our data model. And somebody suggested, hey, have you seen Neo4j? And I thought, no, I haven't. And I looked into it and it just seemed like an absolute fit for that. And it's basically all just been going on from there. And I find it an absolutely fascinating space.
Cool. Yeah. And so I think you've been working, I guess, on Neo4j stuff all the time for about under 2 years?
Yeah, so just over 1.5 years now. So yeah, it's been very good, very interesting.
Cool. Yeah, so Lou works on our pre-sales team in London, and we've had, I guess it was about maybe a little bit under a year ago, we were talking about an interesting data set that we could play with. So I guess I'll let you take over the story from there. So this is a bit of a long in the making meetup.
Oh, it's great. It's fantastic. Yeah, so, I mean, we spend a lot of time talking about different really great use cases with Neo4j and, the really common things coming up like recommendations engines. So how do we, effectively, based on different kinds of collaborative filtering and that kind of thing, entity resolution. So how can you resolve potentially similar things down to the same one with some degree of certainty, master data management, why I got into Neo4j to begin with. And then we start thinking about things like graph analytics. So what kind of clustering you can do and that kind of thing. And it's always great to be able to experiment and work with these different things. And I was sort of thinking, what data set could we use where we can start to test out these different elements? And it sort of dawned on me that actually the BBC Good Food website seemed like a brilliant idea. So you've got a number of recipes, you've got ingredients, because you've got different contributors, you're going to have a situation where things like you'll have cherry tomato, tomatoes. So you've got these like entity resolution options, you've got ways of clustering things out. We start thinking at the algorithm side, we can start to think about what are the common core components of a cake, for example. So you've got a lot of really interesting data and interconnectedness there that you can apply a lot of these use case elements to. And I thought it'd be a fun data set to work with.
Yeah, so I guess maybe we'll switch over to your screen now. So when we first started researching this data set, I guess the step one was we wondered, do they have like an API? Like that was our hope. It was like, oh, there's got to be some sort of API that will let us get a hold of some of this data. Sadly, there isn't, and basically like everywhere on the internet, anyone has attempted to figure out how to build some sort of or do something with this data, they all end up scraping it in some way or other. And so I started working on this scraping approach. I think it was in like May last year was when Lou first suggested it to me, and I thought, okay, I was using Python's Beautiful Soup library. I was like, oh cool, I'll just build myself a little scraper and I'll pull out the ingredients. Maybe I'll get the recipe title and perhaps some of the other information on there. And once I started doing that, I realized it was actually quite tricky to get the actual ingredient itself. So you can maybe see on this diagram, some of the ingredients are underlined. So like, for example, butter and flour and dark chocolate and eggs. But if you take another example, ground almond is an ingredient and that one's not underlined. And so it's quite tricky to figure out, okay, what are the actual individual ingredients in this? So I started off down a massive tangent where I was attempting to train a machine learning model to try and figure out what the ingredients were in this little box, in the boxes on each of these pages. And then Lou came up with a much simpler way to do it that actually worked. So back to you again.
Yeah, so I don't know what happened. I think a few weeks ago, I thought, oh, let's look back into this. And I was just having a look through the source code of one of the recipes. So actually the seriously rich chocolate cake here. And I spotted this rather cute little JSON object here. And I went to Mark and went, oh, hello. I think we may have a nice way of being able to pull this. So it's a bit small, don't worry. We're going to move on to a page where we've expanded this out a bit bigger. But basically, we've spotted this. I thought, brilliant. And I'm just going to shift over here. So this isn't the entire object here, but you can start to see we've got a lot of really useful pieces here. So we've got the information about the author, the description of the recipe. We've got nutritional information. You can see here we've got the ingredient objects, and this is really conveniently packaged in a JSON object. So what we've done with this is we've downloaded a load of recipes and we just extracted out that JSON object. And using that, we've effectively just cut out the JSON object and we've placed that into a flat file. And this is a really convenient way for us to start thinking about effectively loading this into the graph.
Yeah, so effectively we've got a file containing a stream of JSON objects, if you like. I think it's one per recipe, right? So one per page per recipe. I'll share we'll see it in a little bit when we import the data, but I'll share you the link of where we've got that JSON in case you want to play with it yourself. So we've got a question from Jamal Thorne. How did you extract that JSON object from the code? So I've got a Python script that I wrote that does it, and we basically got all the HTML of the page, found sort of where in the page it was, grabbed, and so it's called as like a piece of JavaScript. So you can see it's like trying to add an object. So it's doing permutive.addon web, and then it's sort of trying to pass in an object into some sort of function somewhere in the BBC code. So we grabbed this, effectively the second argument to this function, and then we put it into a Python script. And I forgot there was a library we used to basically decode it from JavaScript to a Python dictionary, and then we printed it back out again into our file as a JSON object. So it's nearly JSON, but it doesn't quote the keys correctly, right? Because you can see it needs to have quotes, double quotes around those to be valid JSON. But it's literally 5 lines of code, but this was significantly quicker than our previous attempt. So I guess we'll go back again to our other page, and so once you get, there's nearly every page has those. I think there are a few that didn't, so we just put some exception handling code in there, and if it didn't have that, we just skipped the recipe. But there were maybe a single figures that didn't have it.
Right.
Yeah, so I guess now once we'd got that data, we were at the point where we need to figure out, okay, are we going to build a graph from this? And so when you're trying to figure that out, you sort of have to do, obviously, like your goal in the end is, I want to get this data into Neo4j. But at the moment, it looks, and so Lou's now put us on a page here where you can see it a bit more zoomed in. At the moment, we've got it as this JSON structure. And we need to figure out, well, how are we going to decompose or destructure that JSON into something in a graph? Because we can't just throw the JSON at the database and go, you figure it out. We've got to come up with a graph model for it.
And with any good data problem, you need to think about how you're going to model that data, and that's very much going to be driven on the kinds of questions you're looking to ask. So again, it's very much question centric about the kinds of questions we're going to ask. And I guess it's probably worth talking about what kinds of questions we want to ask of this data, isn't it?
So we had a few questions in mind, and I guess the thing to keep in mind when you're building these models is that you don't necessarily need to get it perfect the first time around. So if we come up with some questions to build an initial model, and then after a couple of hours of playing with the data, we decide, actually, I want to do some ask some different questions and the model doesn't quite work, it's reasonably easy to go and refactor that model to do what we want. I noticed we've got another question, so I'll address that now. So is this project in GitHub? Yeah, we've got the script that scrapes the data in GitHub, and we've got the data in GitHub as well. We've actually, the queries and loading it is also available as a browser guide that you can run in the Neo4j browser, but I guess we're slightly ahead of ourselves, so we'll show you where that is when we get there. So what we've got on the screen now is a tool called Arrows, and we'll share the link for that in the chat as well. But what we want to do is go, okay, so from that JSON, what graph model do we want to come up with? And the first place to start is we want to create some nodes. And so in a graph model, nodes are they're kind of representing the main bits of data. So like our entities, if you're used to that type of modeling.
Our nouns.
Nouns, yeah, the nouns. Yeah, if you're better at English than me, then yeah, look for the nouns in the data. And so the most obvious one here is that, well, we know we're looking at a recipes data set. So I guess we probably have a recipe of some type.
Yeah.
And so this whole thing is a recipe in some respect. So let's say we've got a node for the recipe, and we might say, okay, I'm going to have.
We're going to have ingredients.
I was going to start even something simpler. So like maybe we've got a title. And so there's two ways that you can do this. Let's just call this chocolate cake, just so I don't have to do too much typing. There's sort of two ways that you can do this. Either you can do the relational style entity modeling, where you just model sort of the types of things, or you can model actual individual bits of data. And what you prefer, I guess, is kind of based on what you're familiar with. I don't know whether you have any better guidance than that.
Yeah, so I think usually the purest view will always be you're going to probably be working with metadata at the end, but it's really hard to work with metadata straight away because it's a level removed. You're thinking quite conceptually there, and it's a lot easier to be thinking about, I've got a chocolate cake, and to make this chocolate cake, it's going to have, I don't know, flour and sugar and eggs. It's a lot easier when you're starting out and you're thinking about the problem that you're trying to solve and the kinds of questions.
Yeah.
It's significantly easier to start from that stage rather than abstracting away and going, well, I have a recipe and the recipe has ingredients and that kind of thing. So generally, certainly when I start modeling from that aspect, I always think about let's work with the physical data that we have and use that rationale around that. And then once we've drawn out, for example, here, the chocolate cake, and the chocolate cake has flour and it has sugar and it has cocoa, we are then in that situation where we can step back and go, well, okay, so what are the, what are the actual components? What are the entities that we're talking about? So, I mean, generally that's my approach.
So if we continue from where Lju had taken us to, so hey, we know that we want to have some ingredients. So let's just copy that ingredients in there. And one potential way of modeling this is to go, actually, I'm just going to put the ingredients onto my, it's now a bit wide, I guess. Maybe I can put a space in there somewhere so it wraps the line. So one approach would be to say, okay, I'm going to put the ingredients as a property on my recipe. So I could have an array property. That would be like a valid thing to do. And that would be perfectly fine if our goal was, hey, I want to just query the recipe and you show me the ingredients on a page somewhere. That would be quite cool. But as Lju pointed out, one thing that we would like to do is sort of do recommendations, and in here, sort of content-based recommendations. So, hey, I've found, show me another recipe that has similar ingredients. And that's quite difficult with this model. Like, we can't go, hey, I want to find another recipe that has ground almonds in. I'd have to go and scan every single recipe and look through all those arrays to find my ground almonds. So that's not such a good model for the questions that we want to try and answer. So we might back out on that suggestion quite early, and instead might say, okay, well, actually, if you want to query through, I like to think of it as querying through something. So if you want to query through those ingredients to find other recipes that might have that ingredient, I want to have it as a node. And the name of that, so I went with, I think in our model, we've called it contains ingredient, but any sort of variant on that explains what you're doing, or what the relationship is fine. So we'll create a contains ingredient relationship. And on this side, we're going to put in the label of this node. So a label is a way of tagging a node. tagging or categorizing a node. It's a sort of grouping nodes so that we can find similar nodes if we want to using the query language, which we'll get into in a minute. And in this case, let's just put one ingredient. So we'll give it a name. Let's say this one's called butter. And we'll save that to our model. And maybe we'll do just one more just so you can see how this process works. And so on this side, we'll say, apparently my spelling is not great. Let's have an egg. So this one could be egg. So we've got an egg and we've got butter, and then we'll put in contains ingredient on there. And if we had another recipe, I'll make one up for this example. We could then connect that. So let's say we've got another recipe that has egg. So we can create another relationship over here. So let's just reverse that. And let's say this recipe is called scrambled eggs. I really hope it's a really fancy scrambled eggs if it's counted as a recipe. We'll see later on that I actually have no idea what I'm talking about when it comes to eggs. I assume scrambled eggs is reasonably easy to make. I have to rely on Lju for the expert knowledge there. So now we've got a recipe, we've got some ingredients. So I think that's reasonably good. That'll probably help us to answer our content-based recommendation question. Should we pick maybe one more thing on here? What would be another good thing? Maybe
author, maybe
author,
they've done a fantastic recipe and we might want to know about other recipes that they've composed.
Yeah, so again, we're probably going to end up with an author, a node representing authors. So let's put one of those in. So in this case, I think, I don't know whether that name seems okay, like it indicates, okay, it's an author, but I suppose you could have also gone for something a bit more generic and say, hey, recipe is written by or created by, but I think we went with author in our domain, so let's go with that. So I think we've got like a partial question. I'll let the person finish it off. What was the name of the author for this one?
Oh gosh,
I don't know. We see it.
Author is GoodFoods.
So this is actually like one that is written by the BBC's content team, I guess. Wouldn't it be better to have a property on the recipe? Manish, you'll have to indicate which what you're referring to when you suggest property. Mitesh has asked the question: does this have a very specific application, or is it just for visualization purposes? Yeah. So once we get on a bit, you'll see that the actual reason for loading this this data into a graph is so that we can do certain types of queries that are quite hard to do when the data is just flat and treated as JSON. In terms of this tool here. This is mostly used as like an early prototyping or modeling tool. And you can there is a way of actually exporting the Cypher that you create here and putting that into Neo4j. So it can actually create a graph for you from your diagram. But yeah, in terms of this meetup, we're just using it as a tool for showing how would you go about modeling the data.
And it's showing, we're basically giving you insight into our rationale behind the approach we used to come up with the data model, how we're going to read the data into Neo4j. So, so like that. So it's just to give insight into that.
And then, okay, so Manish has asked the second part of the question now. So so the reason we don't put the, wait, so hang on, so there's a list of ingredients as strings instead of multiple repeated contains ingredient relationships. So I think you're suggesting why do we not store the ingredients as a property on the recipe. So the reason is that we want to query through those individual ingredients to find other things that might have those ingredients. So you can kind of see on the bottom of this diagram, we've got, if we want to find things that have eggs in, or like if we find a recipe and we say, hey, show me all the other recipes that have these ingredients in, or show me the ones that have the most common ingredients. It's much easier to do that if we have that as a node, because we can easily write a query that makes use of that relationship and sort of say, okay, take me from my chocolate cake recipe, find the ingredients that I have, now find other things that have these ingredients. If we chose to store it as an array, we'd have to write a query that said, okay, find me this recipe, get me all the ingredients, and that's an array, and then kind of go through every other recipe and look through each of their arrays and check every element of their array against my original recipes array and check whether any of those things exist. And it's a much more like, first of all, it's more computationally expensive, but it's also like kind of like unwieldy to write that querying. I guess you would say it's not really using the graph if you're modeling it that way.
And I think to some extent it comes back to what are the questions you're asking, and the questions that you're asking are going to dictate what that data model looks like. So just to give an example, if, for example, we were, let's for argument's sake, say we were building a recipe book or something like that. And in this recipe book, the things that we care about are the authors of the recipes. We care about what kind of mealtime recipe that is. But actually, we never ask about the ingredients, because the ingredients we only ever query and bring back when we actually bring back the recipe. Then in that scenario, it would make very good sense to have the ingredients as properties, because we're never doing any queries that are ingredient centric. Then absolutely that would make sense. But in this example here, because we're looking to do some level of collaborative filtering against ingredients, then it makes sense to pull these out and they become nodes in their own right.
Yeah, so I guess on this one, and one that we haven't pulled out as a node and didn't in this example, is skill level. But you could imagine if you were building, like if you had like, I think they give quite coarse skill levels, but imagine if you had like really fine-grained skill levels, like if it was, maybe it was like a set of recipes for a budding chef to learn. Yeah. Maybe that would be a more interesting one. You could say, hey, I'm at this level of some sort of chef training. And you say, hey, show me what recipes are in my range of ones. Then maybe that skill level makes sense to pull out. Yeah. So we've got a couple of other questions. So I guess let's address those. And I think that probably covers the modeling. That probably is enough for the modeling. But we can kind of do the same exercise for figuring out, okay, what do we want to do with keywords? Do we want to do something? What else have we got on there? Courses, cuisine, channel, I guess. Yeah. And so there are, and collections. And so you'll see what we came up with. Servio asks, can Neo4j handle billions of nodes and edges? So yeah, we've got people who are working in databases with those sizes. So yes, we've got it is possible to do that. John O'Gorman, could you model ingredient nodes the other way around? Node, butter, label, ingredient. So wait, so I see what his. Yeah, so just to clarify here, so where you see, when you see the name inside the node, inside the circle, that's the label. So the label here is ingredients, and this is the property. It's just maybe it looks a bit counterintuitive in arrows, but absolutely, John, what you're saying here, if I double click here, you'll see the caption. So caption is the label as well, synonymous. So the label here is ingredient, and the property here will be the key value pair of name to butter. Okay, cool. And then our last question, which will be, we're getting onto on the next slide, is can we do an automatic import from the obtained JSON to Neo4j? So we can go from JSON to Neo4j, but we have, as I say, this is like the first step. We've got to say, okay, for what should I do with that JSON? Like, what projection do you want me to do from that JSON into a graph model? So that's what this is like the first step of that process. So I guess that's probably, you probably got, hopefully that's enough to get the idea if you wanted to continue this and add some more to this model. But now we're going to have a look. I guess I'll let Lou talk through a little bit of the import approach. Sure.
So what we'll highlight here, this isn't the complete import statement that we run to get the data into Neo4j. So this is just a small portion. And as Mark said, we have the scripts both available in the Medium blog posts that we've put out and also in the GitHub repository. So we'll talk a little bit about what we're doing here in the script. So first and foremost, to be able to run these scripts, you will need to have multi-statement enabled in your Neo4j browser. We will show you how to do that in a few minutes, so don't worry, when we're going through the queries, we'll show you where in the browser you need to set that. But you get that set, and then effectively what that means is you can execute multiple Cypher queries within browser. So what we do is we're going to set a number of indexes, and we're creating indexes on certain properties within our nodes. And the reason why we're doing this is because we're going to be importing a lot of data and we're using the merge keyword, it just means it's going to speed the whole process along. And what you'll spot here, we've got the merge keyword here. And what we do with merge and what merge does is it goes away. It has a look at the item that we've specified. So what we're saying is going to be the unique constraint for the node. So for example, here we're saying that ID is the unique property for recipe. And what we do with the merge will basically go away. It'll go and have a look. So if we've got indexes, it'll go and check the indexes to see does the node type of recipe have that ID. If it doesn't exist, it'll go away and create that new node. If it does exist, it'll do nothing. So that's why we put the indexes in. It speeds up that performance. So we do that, and the next bit I will flag here is we're setting a parameter here, so params JSON file, and what we're doing here is we're giving a link to where the flat file is, where we've got that file of all those JSON files, JSON objects. And the reason why we're doing this is because when you look at the full import script, you'll notice we re-import the file several times. And the reason why we do that is we're trying to make this query as efficient as possible. And this stops this concept of an eager query. And sort of very briefly, an eager query hangs on and keeps in memory all the local references of the nodes that we have when we've been importing the data, because it's trying to hold on and say, well, I might need to keep this because I need to add a relationship somewhere, or I'll need to connect something in some way. And we don't really need to do that for this data. So this is why we've taken this approach. Mark has written a very good blog about eager queries and approaches you can do to reduce the eagerness of them. And I think we will sort the link out for that, so you've got sight of that as well. But that's basically what's going on here. And
I guess one question from Mitesh is around, can we explain the indexes that we've got at the top in a bit more detail? So the question is, are we indexing it to make the queries faster? If yes, why are most of them indexed? So in this case, the indexing there is actually as part of the import process. And the reason we do that is because I guess we can maybe talk through one of the examples. So we're using for example, this merge that you can see, merge our recipe. So what that's doing is merge is a clause that says, hey, I want to create this thing if it hasn't already been created. And so you see on the first line, we create an index on that recipe. And so what it means is that when we go and check, hey, does this recipe exist for this ID, it means that we can just go in the index and check, does the recipe exist, rather than having to scan through every single recipe. And so this is like quite a common thing that people sometimes run across when they're importing data, because it will get slower and slower as you do more records. So if we had no index on the recipes, the first recipe we put in, pretty easy, right? There's nothing there. Okay, create it. Second recipe, it's going to go and scan. Okay, does my ID match against one recipe? By the time I get to like recipe 10,000, I'm checking 10,000. When I get to 20,000, I got to check against 20,000. Whereas if we put the index on, obviously we've got a log n time to check, does this recipe already exist? And so in this case, all of those indexes are being used because those are the properties that we're using as part of the import. More generally, separately from the import, you would put indexes on properties that are going to be used, that you're going to start your queries from. So if one of our queries was, hey, I want to find all the ingredients or all the recipes for eggs, then it would be reasonable to put like an index on ingredient name. Now, if one of my queries was, hey, find me all the recipes with the name chocolate in, maybe I want to have an index on recipe title or recipe name. So we don't actually have that at the moment. We've got another question here. Well, actually, we've got a few questions. I guess we'll go from maybe we'll go from the top. So John clarified a question from the previous slide. Could you make the label butter and the property ingredient so that butter is always butter, even if it's not used as an ingredient? So in this data set, it is always used as an ingredient. But yeah, if you had a more generic data set where sometimes it could be used as an ingredient and sometimes it was used as something else, that would be valid. So you could, like, one way of doing that would be to come up with sort of a more generic label. So if there's a more generic way of describing what butter is, perhaps you define it by what, like, the family of things it comes under. That would be valid. Equally, like, another approach people sometimes take is actually to do multiple labels and sort of tag the node with each of the the roles that node's playing. So if it's playing the role of ingredient, cool, we'll tag it as an ingredient. If somewhere else it's playing the role of, I don't know, like, what would be a better example?
Well, no, but okay. So I mean, one extension we could do here. So let's say, for example, we wanted to do ingredient families. So let's take we'll take butter as an example. So let's say, well, we've got so we know we've got butter, but actually it would fit into a hierarchy of cooking fats, and within that hierarchy of cooking fats, we would have, I don't know, olive oil, sunflower oil, rapeseed oil, coconut butter, etc., etc. And what we could do is we could say, well, we started off going, well, actually, butter, olive oil, etc. are ingredients. But further on down the line, maybe we've done some analysis and say, well, actually, yes, they're all ingredients, but they're also all types of cooking fats. And then what we could do is we could add another label there of saying cooking fats. So you can add multiple labels, and like this we start to get different viewpoints and slices and hierarchies based on the kinds of questions we're looking to ask.
Cool. So Manish, your question about the syntax of this query, I think it's just because maybe the text is a bit small, but we do actually have curly brackets in there, as you suggested. You can't put parents in for the properties. And then Marco has a question: quantities and cooking methods, are they entities or relationships? So I think what you're asking really is actually, are they properties or are they entities connected by a relationship? And so in this case, I think we've just set those quantities and cooking method. We've just set it as properties on the node. And then Manish observes that we're using, as you point out on the questions, we're using the APOC library, so awesome procedures on Cypher, and there's a load JSON amongst many other data formats procedure in there that we can use to process. In this case, we're processing JSON, but you can also load data from JDBC. So you can get data from any relational database using that. You can load XML documents. I'm sure there are many others that I've forgotten. And then we've got another question from Ashvin. Is it possible to mention all properties in the merge statement instead of set? So that's another thing that people sometimes do when they first pick it up, is to put all the properties inside the curly brackets. It has a slightly different syntax than what we're doing here. So anything that you put in the curly bracket, it uses every single property that you put there as effectively like as your uniqueness of this node. So it will go and check, can I find a recipe with this ID and this cooking time and this preparation time and this name and this description and this skill level, which, as you can imagine, is quite slow as your number of recipes increases, because it needs to go and check against every single recipe to make sure each of those values matches. Whereas in our case, we know that the recipe is identified by that ID property, so there's no need to put all of them in there. So we kind of achieve the same thing, just more quickly. And one other thing which Lou pointed out when we were talking about this just before we started was, with the set command, you can also use it on create, and if you only want it to apply the properties when the recipe gets created. And there's also another variant called on match, which would only run if it was already there. So you might want to use that if you said, okay, I want to maybe I want to keep a track of when was the last time this recipe was found in my import script. So maybe we keep like a timestamp or something, or like
a counter every single time somebody does a search for it. Yeah.
Cool. So I think that's probably, we're probably good enough to go on to the next bit, and we'll share the links that Lou's described as well. So are we ready? I think we're ready to go. Go into the Neo4j browser now.
Yeah.
So we're using an instance of the Neo4j sandbox here, and we've made a guide which contains everything from this session in case you want to play around with it afterwards. And you can type in :play recipes. So maybe I'll quickly just show you what happens there. And it will give you a guided sort of a walkthrough tutorial that you can follow. And so you can click on these buttons here. So this is the script. So this is like the full script. Lou showed a little portion of it in the slide. So if we go to the top, you can see here we define the indexes. We create a parameter to indicate where our file lives. So this is where the stream of JSON objects lives. You'll notice that we're actually like executing lots of queries all in one hopefully in one statement. And so if we go down to the little cog on the bottom left, you by default enable multi-statements or query editor is off. And so if you want to use that feature, you'll need to turn it on. Otherwise, it will tell you, hey, your Cypher has a syntax error. And so you can see this is quite nice. If you've got a script, previous to that feature, you'd have to go and you'd either have to manually feed your script in, or you'd have to use the Neo4j driver and feed it in like that, or you'd have to go and use the Cypher shell and feed it in like that. So this is like a significant usability improvement for, hey, I just want to load this data and I'm using this this browser tool. I'll just quickly show you what else we've got in here. So we've got you can run a schema query. I guess maybe we'll show how to run that. So just a quick schema query. So you see, so this is what Lou referenced before, that the proper way of doing data modeling would be actually we need to work out, okay, what entities have we got, what relationships are connected between them, and you'll notice in that import query, there's nowhere where we do hey, I want to create this schema and I want to make sure these properties exist. The schema kind of comes with the data. So as you put new data in, the schema evolves with it. So if we were to create to write another import script that added in some other node labels, we would see those appear on this diagram. And so you can kind of see our full diagram here. So we've got a recipe. Recipe is basically the center of this universe. It connects to a collection, a diet type, an author, ingredients, and then I can't remember if I said collection, so I won't be saying that again. And then once we've done that, we can run all sorts of queries on here. So I'm gonna hand back to Lou to talk us through. But if you want to play with this yourself, :play recipes is the command. You can run that on a Neo4j instance anywhere. Either you can use one if you search for Neo4j sandbox. I'll also put a link there while Lou is showing the queries. Or of course you can do this on a local Neo4j. It will pick it up as there as well. If you run a Neo4j desktop instance, you can do it there too. So Lou's now going to just take us through what sort of queries can we do on this data set.
So I've got some basic queries. So a top tip to you all. What you can do, if there's certain queries that you're working with or you run several times within browser, when you type your query in here, you can press the star on the side, and what that will do is it will save it to favorites. So for example, let's do db.schema. And let's say this is a query I like to run very often. So I'm just going to quickly give it a comment. And what we can do is you press the star here and it will save that query. So when you click on the star here, you'll see it's saved my query. So rather than me having to type it again and again, I can just click it and it'll save it. And I've used this approach here for today's session. And I've put in some queries here under BBC Good Food. Many of these queries, again, you'll see if you run play recipes that Mark showed earlier. So let's start off with finding some recipes that contain chocolate. Who doesn't want some chocolate?
Yeah, we can tell what your favourite food is, I think.
Can you tell my motivation? So it's very simple here. So we're creating a pattern. And for those of you who aren't so familiar with Cypher, what we do is we're creating a pattern. So you can notice here we have this common feature of the colon, both in this part here, which is the nodes, and this part here, which is the relationship. And basically everything to the right of the colon will either be the node label or the relationship type, and anything to the left of the colon, if there is anything, will be a variable that we're creating. So basically what happens here is what we're saying is match recipe, and whatever matches the argument will have a variable placeholder for the node here called rec. And question that we're asking here is match recipes and store those recipes that match into this variable rec that have a relationship of contains ingredient with a node type of ingredient, and inside the curly braces we're stating some properties here. So here what we're saying is we want the ingredient to have the name of chocolate, and some of you may be more familiar with seeing so if we want to use a where clause, then some of you may be more familiar with something along the lines of where I.name equals chocolate instead of using this bit here. So either way works. So this is the equivalent of the previous query. Right here, we're going to look for some recipes that contain chocolate, and we're going to return the name, so recipe name, but we're storing it as a variable rec, and the identifier. So if we run that, we've got some recipes here. Now, taking this a bit further, what's caught my eye, what did catch my eye? I think it was there were some truffles that I looked at.
Yeah, it was the truffles. I think you like this truffle star cake.
Yes, the chocolate truffle star cake.
Yeah, it's a shame we can't get pictures in the Neo4j browser, otherwise this would be an extremely hunger-inducing bit of Cypher.
Maybe that'll be next time we can write an application that we show the pictures.
Yeah,
Oh.
yeah. I don't know if we'll actually finish it though. We'll be like, oh, I've got to make a cake.
So well, look at this. So what I'm going to do is I'm going to take the recipe ID for the chocolate truffle star cake. So I'm going to grab that, and I want to find out what the ingredients are. So
yeah, because you're trying to check, like, do I have the ingredients in my in my kitchen to make this?
I know. Could you imagine the disaster if I go in there and discover I don't have any vanilla or something?
I don't know. Yeah, let's see what ingredients.
What do we need? So again,
we're doing, it's a little bit similar to before, right?
Yeah, absolutely. So same ideas. So we're putting the recipe identifier in here as the property that we're interested in. And then again, what we do, we've got the variable here I, and we're going to pull these back. And again, what we're doing is we're going to return the ingredient names here, and we're going to order them. So I want them in alphabetical order. So just order by I.name.
So in this one, the I, does that matter? Like, it can be anything you want.
It could be anything you like.
Okay, cool.
I could have called it Dave, but I decided to be a bit more conventional and call it I.
The Daves, any Daves watching would be quite happy to see their name in the query, I guess. Cool. So what have we got there? So we've got chocolate. That's good. We've got chocolate and dark chocolate.
And cocoa powder.
Yeah, so I guess that points out like a thing, and white chocolate. This is like a thing that we're not going to cover today, but like as an interesting like future extension is like there's loads of types of chocolate, and there's nothing in the data set that indicates, hey, these things are actually all the same. Like there's
or they belong to a family. They've all got chocolate in there. So absolutely, that's something we definitely want to look at soon.
Yeah. Before we go on to the next one, let's just loop back. So we've got a question from Leo Vlogs. Can you explain very quickly what is an APOC library, please? So, Leo, I've put about 2 comments above where you asked that question. I've put a link to the documentation for APOC. So APOC is a plugin library for basically extending Neo4j with extra functions and procedures. I won't attempt to summarize what is in it because there's more than 400 or maybe even 500 now different things, but it kind of has stuff like data integration tools, data loading tools. It has like utility functions for massaging data. It has sort of data cleanup tools. I don't know what else it has. Can you think of anything else?
Time to live, virtual graphs, all sorts.
There's lots of different things in there. If you use the Neo4j desktop, APOC is one of the it's kind of one of the plugins that you can get by default. So there are 3 of them. So there's APOC Graph Algorithms and the GraphQL plugin. And if you create a project in the Neo4j desktop, you'll be able to see in there. You can just one-click install the APOC library. I'll send you I'm going to put a link to a blog post that our colleague Jennifer Reif wrote. Where Jennifer sort of talks through like step by step how do you install plugins and what the different plugins do. So that might be helpful. John asks, to your point about chocolate variations, is it easier to do that if chocolate is a node or property? So this was around, can we figure out that, hey, all those things are chocolate?
So I've got a bit of thinking around this, and there's a couple of ways to do this. So in a purist sense, chocolate, white chocolate, dark chocolate, they are all properties because we're doing that key value pair of name, colon, and what the value is. Now, there are a few ways we can look at this, and the real fun thing with regards to that is, we either do like the sort of, your sort of normal things where you may look at things like Levenstein distance or something like that, where you see how different the words are. But what we're quite keen to do, and definitely this will be coming out soon when we start looking at different approaches, is how can we use the graph and the relationship between, say, the different types of chocolate, that we can start to put levels of certainty to say that these are all part of the same group. So, watch this space.
Cool. And then we've got one more question, I guess, before we do our next one. So from Ashvin, can you explain the relationship direction? So in Neo4j, all relationships that you create need to have a direction, so that we say it goes from a source to a target node, or a start to an end node. It doesn't actually matter. Like in terms of querying, you're able to query outgoing and incoming relationships pretty much the same. There's only like ones that but you would normally want to indicate, okay, which direction am I working with? The classic example of that is, imagine that you're modeling the Twitter graph, and you want to capture the follows relationship. And let's say we're doing like a really popular person. So let's say we're modeling Lady Gaga, and we want to say Lady Gaga follows these people. Lady Gaga is followed by these people. We don't want to accidentally leave that direction off, because there are going to be like 70 million people who follow Lady Gaga. And if we're just trying to find who does Lady Gaga follow, we don't want to go and have to look through all of those people. In this case, the way I came up with that model was, I just thought, how was I thinking about it? And I thought, okay, the recipe contains the ingredient. Equally, you could probably argue the ingredient is in a recipe. I don't know that there's necessarily a correct or incorrect way to do it. Yeah,
as long as you're consistent. Yeah.
Cool. So should we go back to our right? So we've got quite a lot of ingredients we need to get into the kitchen to make this cake.
I know it's looking a bit scary, but so let's take it a little bit further, and we start to think about, and this is a very, very basic recommendations query, but just to give you a flavour. So going back to that chocolate cake, so let's say we really like that recipe, and we want to find out what other recipes did the author of that chocolate cake write. And how we do that is, you can see here we've got our reference to recipe, and here's the recipe identifier here. And then what we do is, we've got this pattern. So we're going from here, then we're saying, well, the recipe was written by this author. And then what we're saying is, what are the other recipes has that author written? So we've almost got this sort of palindrome pattern going on here. And then what we're going to return is the other recipes that this author has written and the IDs. So we've given it a start point here, which is his recipe ID. We're saying our pivot point is this author, and then give us the other recipes that the author has written. And again, returning the recipe name and the ID. And there we go. We've got a list of these.
It's disappointing that this person is not like a mega chocolate cake aficionado and just only reviews chocolate cakes.
We should definitely look into that. So I think we'll hand over to Mark, and we start looking at how we can be a bit more specific with the recipes.
Yeah. So for the next one, we wanted to have a look at, so this is kind of like, what can I make if I've got some specific ingredients? And what can I make if I've got someone who's really allergic to stuff, like me, who's coming around, and I want to make sure I don't kill them in whatever I cook. So we're going to have a look at how can we find things that contain ingredients, and how can we have a look at things that don't exclude ingredients. So the simplest way would be to actually just do something like a query like this. So what we're saying here is, hey, I like stuff that has chili on. So I've got it's a very simple taste, and I want to say, hey, show me the ingredients or recipes that have that contain the ingredient chili. So we're doing kind of a similar thing as Lou showed us in the previous query. So this time we're just looking up, find me all recipes, where, so the where clause is for sort of filtering the results. And so what we're saying in this case is, I want to find nodes where there's a relationship from my recipe called contains ingredient, and on the other side there should be a node with the ingredient label with the name chili. So i.e. in English, find me recipes that contain chilies. So that's reasonably simple, I guess. And we get back lots of different things. So depending if this is like dinner time, maybe you get some ideas on here. But you can see we've got green apple salad, we've got some Korean fried rice, we've got all sorts of things. So smoky spiced smoky barbecue chicken. So it's really broad. Like, this is not like, I guess we probably wouldn't want just chili as a filter, but maybe we've got two things we want to filter on. So perhaps I'm fancying chili prawns. This would not be for me. I can't eat prawns either, so this is not a great one for me. But like, the simplest way to do that, like to extend the query, would be, okay, well, we'll just add another and statement, and we'll find ingredients that contain both of them. So that works. You can see now we've got things that contain prawns and chilies. Probably quite nice, quite tasty if you're, I guess if you're in our time zone or a little bit ahead, it's sort of coming up to dinner time. Disadvantage of this is what happens if I want to look for 3 ingredients or 5 ingredients. I'm now going to, like, my query is not very flexible, but we can make it, we can refactor it to make it more flexible. But the way we would probably want to use it is actually we might want to pass in the ingredients from a parameter. And so Lju showed this before. This is how you can set parameters in the Neo4j browser. So what we're saying here is I want to create a parameter called ingredients, and I'm going to give it 3 ingredients: egg, onion, and milk. And so let's just set those up. So there we go, we've got our parameters. And then we can, so I just scroll up a bit. We can use a function. It's a collection function called all. And what it does is you can use it to basically iterate over a collection of items. So in this case, it's those ingredients, so egg, onions, and milk. And then it checks, does a predicate that on each of the values in that collection, is it true? So every single predicate that we execute needs to be true. And the predicate in this case, so it's just some piece of code that returns true or false. And in this case, it's this piece of code that I've selected here. So it's basically checking, does there exist, i.e. is there a relationship called contains ingredient from the recipe to an ingredient with the name I, where I is one of the values in this list. And it just goes through this list and checks for ingredients that contain all of those things. So these are things that contain milk, onion, and eggs. And if we wanted to change that and say, hey, actually, I want to find things that contain egg, onion, milk, and apples, I can just update my parameters. And one nice thing, it's been in the Neo4j browser for a while, but you can just hit a little refresh on there. And now there's only one thing. So I have to have country-style toad in the hall if I want to ensure that I have every single one of the ingredients. You can also vary this. So you could say, I think it's any will check that it has at least one of the ingredients. But what I wanted to finish this section off with is to show you another function called none, which is really handy for excluding things. So I made like an extension for this query here. So imagine we want to make something with coconut milk and rice, but I'm allergic to eggs and milk. So we'll make another parameter called allergens. And then this time we can find a recipe for me. So if we just make that a bit bigger, maybe. So we're saying find me recipes where it contains all of the ingredients in my ingredients parameter. So that's exactly the same as before, but none of the ingredients in the allergens list. And then the rest of the query is exactly the same as before. So I'll just, yeah, there we go. So these are some of the things that I would be able to have. Again, with the query, we could say, okay, imagine we had someone else coming around who's allergic to mango, for example. So you can see number 3 has mango in. So if we want to get rid of mango from our list, in the wrong key, there we go. So we just add mango to the allergens list. And you can see, like, when it runs these, you get a little tick to tell you it's done. You can have a look. It says, hey, parameter was successfully set. That's great. And then we can run it. And now the mango will be gone from our list, and so we've filtered it down a bit more. So I guess maybe we have some questions, and then we can wrap up.
So we've got a couple of questions about how would you manage amount properties for ingredients, and yes, absolutely. So it always comes back down to the kinds of questions you're asking and how they're going to be referred. But absolutely, you could, in the contains ingredient relationship, you could put a property on there, and the property could be amount or quantity, and then perhaps you can specify what type. So it could be, for example, amount 25 and type could be grams or something like that. So absolutely, that's one approach you could do. If there was something a bit more generic, so let's say, for argument's sake, all of your recipes were always going to be in quantities of, let's say, cups, like some more sort of imperial US style place. And let's say, for example, you always have very specific things. Then for speed, you might say, well, actually, what I'm going to do is I'm going to change my relationship type from contains ingredient to contains 3 cups of, contains half a cup of, that kind of thing. And then that way you have a much faster query speed, because you're not having to scan through the relationship properties. That's a slightly more complex thing where you're looking for really fast performance. But absolutely, you can attach properties onto the relationships for the amount. So that is definitely one approach to do that.
Then there's a question about the pipe. So it's not, the pipe character. So we're not actually using it as a pipe operator in this case. It's effectively just being used as a projection. So just to show you like a really simple example of how you can use it. It works on collections. So if I said I've got a value in a collection, so imagine we've got like a range of numbers from 0 to 10. I could use the pipe to say, I want to double each value. So you see here, I said, hey, give me the numbers from 0 to 10, and then apply this times 2 on each item. And so what we were using it for in the other place was to just grab the name for each node rather than, so I guess that's actually, we were using, this here is called a path expression. And so what it lets you do is if you can take like some part of an earlier part of the query and then kind of apply effectively like a match query to that node in this case, and get what's at the other end, which is an ingredient, and then just get the name of the ingredient, and it will give you it back as an array of values. And you could choose to say, hey, just get me like the first ingredient, for example, like this, or you could say, hey, get me the first 5 ingredients like this. So the syntax is sort of, it's a little bit based around GraphQL, and it's a little bit based around how Python collections work. Is this being recorded? So Jamal, is this being recorded? Yeah, so this is recorded exactly at the same URI where you are now. Oleg, for your question about can you show how to use a similarity algorithm to find similar recipes? That'll be, I think, for part 2 of
part
this,
3.
or part 3.
Part 3 of the Medium blogs, part 2 of the video.
Okay, yeah. And then, does Neo4j have a way to manage recipes in different languages that can connect, say, to an English equivalent? That's a good question.
I think that's going to be a modeling exercise. So I think generally, I think we'll need to investigate, but generally there will probably be some work, probably quite akin to a knowledge graph, where maybe you have eggs, and then maybe in, you then connect it to what the French equivalent is for eggs, which is oeuf, and maybe like that kind of thing, Spanish huevo. So effectively, you may well be, you may be mapping that, so that some of that will be a modeling exercise about how you want to represent that, and then potentially you can sort of do it around that way. Yeah,
and then Leonardo, for your question about Neo4j 3.5.3 and Neo4j 3.5.2, I guess this is probably not the easiest place to debug that. So I would suggest at the top of this chat, I've put a link to the community site, and I would suggest if you can post it in there and sort of show like what error message are you getting, and then we can either Lou and I or somebody else, if they get there quicker, can help you figure it out. Kat asks, is the pipe similar to a Python Lambda function? Yeah, I guess it is a little bit. Yeah, so effectively on the other side of the pipe, you've got in our example, in the value example that I gave, you have access to do whatever you want with value. So yeah, I guess it is pretty similar to the Lambda function. What else did we have? Do we have some other questions?
Oh, yes.
Can Cypher read rules and update the database like a rules engine? I would say this not directly in Cypher, but in the APOC library that's linked a little bit up the chat, there's a concept of triggers. So you can set triggers to apply like pieces of Cypher based on something happening. And I think you could maybe need to have a look at the documentation of that and see whether it achieves what you want. But I think that would be the closest that you have for that.
And our colleague Max Damazi has written some very interesting blogs as well. When you want to write some real sort of heavy-duty rules engines and things as well, he's written a lot of content around that too.
Okay, another question. Could you please add, how would you go about classifying a list of ingredients to a collection or diet type? So that there, they've actually given it to you, right? In the JSON, they already told us. Maybe I can. This one. So you see here that I've put on the screen on the right-hand side, they've actually already told us what is, which diet type this belongs to. So where is it somewhere?
Something like indulgent.
Yeah, so they've given us like, and so these are the collections. So all we did for this was we just took that array of collections and then we created a node connecting to it. Creating oh, you mean like a machine learning type classifier? That's going to be like part 4. Yeah, I guess if you can, again, maybe the community side is the best place. If you can describe, like in a bit more detail, what exactly do you want to do? Like, is it like if you can narrow down the problem a bit for us, we can try and address that in a future talk. Is there any plugin that can do predictions or work with neural networks with the data stored in Neo4j, such as an integration with TensorFlow or Keras? Our colleague Andrew Jefferson and David Mack have been doing some sort of, I guess, work around this. And so I'll link to that. It's they've written a bunch of blog posts. They are called Octavian AI. So if you search for that, you'll find it, but I will put a link there. I guess maybe we can do a quick wrap up now, and then if you have any other questions, we can handle those on the community side afterwards. So maybe should I stop sharing this screen again? So we'll come back to us. Cool. So yeah, I guess I'll let you wrap up. So we talked a little bit about some other things that we want to do.
Yeah, absolutely. So I mean, just sort of what we've shown you today, we've shown you how to model and import the data. We've given you sort of insight into the kinds of questions we're looking to ask, and this is pretty much going to drive, the data model that we've done. Maybe in the future we may need to tweak it slightly, and absolutely we'll talk about that. And we've given you a very, very simple idea of how you do a very simple recommendations engine. How can you include and exclude ingredients? Please, you've got the play recipes guide. Go have a look, have a play. What we're going to be exploring next time is how can we start to do different kinds of recommendations. So the recommendations could be, for example, on certain ingredients. It could be on author. There are various elements there. So that's definitely what we're going to explore. Have a go. Have a go beforehand, and let's see how we contrast and compare. Yeah,
and I guess before we end, if you enjoyed the talk and you think it would be useful for other people, don't forget to like the video on YouTube. And we'll be back again next week. Next week we're doing a meetup on the Tuesday. So I think it's a little bit earlier. So if you're in, it's probably a little bit early for the West Coast in the US, but it should be okay for other time zones. And I'll be with my colleague Michael Hunger, and he's going to be talking about how we can build what he calls tag overflow. So he's doing using. So maybe this might be interesting if you're interested in the similarity algorithms in the Neo4j graph algorithms library. We're going to be showing how you can apply those to the tagged data on Stack Overflow to sort of find like a taxonomy in there. We got a final question, Leonardo. I'm interested in AI with Neo4j. Yeah, maybe bring your question to the community site, and we can talk about it a bit there. I'm currently working on a data science and machine learning online training course that we're going to be launching hopefully in the next couple of months. So maybe that'll be interesting for you and give you some ideas. Otherwise, though, I think we should probably wrap up because it's probably time for people to go home or get back to work. So thank you for spending the last hour with us. And I guess thanks to Lou for the idea and for all the work around building this. And we'll see you all next time. So thanks. Bye-bye.
Bye.